Hello guys, welcome to my Cloud Guru channel. Today we are going to discuss or extend our discussion on Azure Site Recovery. As we have seen in our previous demos for ASR implementation and design, that there are multiple variety of the disaster recovery solutions possible with and without ASR in Azure platform. So as you can see in my diagram, this is the design which we tried in our demo. We had two web servers in Central India region, and we implemented the ASR, we replicated the VMs, and we put the application gateway in a separate VNet in a third region, which was UK South. So we saw that in this design we are saving some cost. Of course, we are saving the cost of the application load balance, application gateway in the secondary region, the DR region. But it has a flaw as well in the design, and that in case of the DR, in the case of the actual DR, what we had to do was to do the site failover to the East US region, which was our DR region. But at the same time, we also have to remove the VNet pairing from VNet 02 to VNet 01, and then we had to add manually pairing and VNet pairing between VNet 02 and VNet 01 ASR. So this was the two-step we need to do in this design. Now there are different variety of this disaster recovery possible. So let's look at the option number 2, which is here. In option number 2, what we did was, or what we're going to do is that we introduced Traffic Manager. Traffic Manager will be able to it is basically it's a global service from Azure, which allow you to redirect the traffic to multiple site or multiple regions, active or active passive. It supports multiple kind of algorithm. We'll talk about those algorithms in detail. But if you look into this solution, we implemented Traffic Manager in the front as a global service from Azure, and then we implemented the active passive layout using the priority algorithm. So when we implement the priority algorithm, we will redirect all the traffic to our application load balancer in Central India region, and with the higher priority. And as you can see in the diagram, that the application load balancer in Central India region will become the primary interface to the applications running in Central India region. And then in the back end, we are still replicating the VMs using ASR to the secondary region, which is basically in East US. The Traffic Manager will never redirect the traffic to the East US because we are putting a lower priority on the endpoint, and as a result, all the traffic will always go to Central India region. Now, if there is a regional failure on the India side, Traffic Manager will start redirecting the traffic back to our East US application gateway. And at that time, of course, our backend servers are not available, so you have to do the site recovery activities, make sure that the ASR failover is done, and our web servers become available in East US region. So as soon as the East US region servers become available after the ASR failover, the application load balancer backend pool health check probe will become green, and our application will be up and running through application gateway in East US region. So this design is again a little bit expensive because we are introducing Traffic Manager. You have to pay for the billing for the Traffic Manager. You also have to pay for the two application gateway instances, one in India and one in East US. But in terms of failover, this is basically a quicker option, or in terms of the recovery steps. Of course, this option is better as compared to the option 1. Now, some other varieties are also possible depending upon your application. So for example, if your web servers are completely static, right, and they are not changing any data, there's no dynamic changes happening, and we're only talking about the static websites or static applications. in that case, you might not require an application gateway, or you might not require ASR, for example, to replicate the servers from Central India region to East US region, for example. So the option number 3 talks about this possibility. Here you have 2 web servers in the availability set in Central India region behind the application gateway, and this application gateway can, of course, can go to any region, whether you can put in Central India or you can put in any other region. And of course you still have the traffic manager, but the difference is that sending the traffic to the application gateway in Central India for the production side, and for the DR side, we are compromising, we are reducing the cost, we are removing the application gateway, and we are compromising the performance. We're going to only one web server in the case of the actual DR. Now, for some organizations, this solution may be acceptable. Some organizations may not accept, because from a rule of thumb, the DR should be identical to the production side. But some organizations do not want to spend money, and they want to save cost on the DR side, and they say, okay, if the DR happened, then we can always modify the implementation in Fly to match what we have in production. But if it doesn't happen, why to pay, keep paying money for the multiple instances of application gateway, for example. So in this case, we assume that there is no ASR there. The web servers are completely static. Web 03 is there, which is exactly copy of the web server 1 and 02, but we are not replicating through ASR. And Traffic Manager is just sending the traffic to the web 03 with the lower priority. So all the traffic will be going to the application gateway in Central India, to web 01, web 02 on the back end. But in case of actual DR, what happened is that the traffic manager will start sending traffic to the web 03. Now, if web 03 is down, because organization wants to save more money, they have to bring it up. And as soon as you bring it up, the traffic manager will send the traffic to it, and the application will be again up and running. So this solution is much simpler and much cost effective as well, but it is not a best solution in my opinion, because it's not match, the DR solution does not, or DR design does not match exactly identical to the production. So I would say that depending upon your scenarios, you should go with option number 1 or option number 2 with the ASR, and option number 3 is again an option, but it's basically not something which I recommend. Anyhow, so in our today's demo, we will go and test the traffic manager implementation, and how the traffic manager can send the traffic back to the application gateways, and how it controls the failover. So we will do the demo for this implementation, or this Okay guys, so let's start our practical demo. Now, as you can see here in our screen, that we have deployed 2 VMs, web 01, web 02, and both of them are deployed in Central India region. And if you look into the configuration of those virtual VMs, basically they are deployed with a standard B2S size. They are running Windows 2019, and I have deployed it with the marketplace image of IIS Windows 2019 edition. It did not give any public IP, it just has private IP addresses, and they have been deployed in VNet 01. So everything looks okay here, and the web 02 is exactly a replica of web 01. So our next step, we also have deployed a private DNS. So if you look into the private DNS configuration, we have deployed a private DNS testlab1.com, and it has the virtual net link to VNet 01 and VNet 02. The difference is between VNet 01 and VNet 02, that as per our design, VNet 01 exists in Central India region, while VNet 02 resides in East US region, which is our DR region as per our design. So our next step is to configure the application gateway. So let's go and deploy our application gateways. Okay, so for the application gateway, let's go and deploy the first application gateway. We have to, according to the design, we will deploy application gateway instances in both Central India region and East US region. So test RG is our resource group. We can call it Application Gateway India. Basically, I'm selecting standard version 2 as a tier of this application gateway. As per the best practices, you should enable the WAF, and you can go for the WAF or WAF version 2 from security point of view, from best practice. I'm not going to enable the auto scaling, so I'll keep the auto scaling no, but I will deploy 2 instances for this application gateway in India region, and we will go and deploy 1 in each zone. And then VNet 01. Next step is the configuration of the front end. Now it's complaining that it does not have the proper subnet, so let's see. I thought that I created a separate subnet for it, but let's see if it doesn't. It may have something else as well, so probably that's why it's complaining. So let's go and create a new subnet here. Let's create a new subnet, application gateway subnet 2 in India region. We can give the IP, let's say 10.1.13 or 04. So now we are adding a new subnet. For some reason it's complaining about the subnet that has something else. So we'll go back to our application gateway again, and we will put in subnet 2. So as you can see, this is our configuration of the application gateway, and let's define the front end. We are going to give a new IP, application gateway India pub IP. Okay, so this is the public IP, and then the backend, we have to add a backend pool here. Let's call it backend pool 1, and here you have to add the target. So for the target, basically we have 2 web servers, so let's add the 2 web servers here. web01.testlab1.com, where remember that we are putting the fully qualified domain name, so web02.testlab1.com. So we added these 2, web1 and web02, web101, web02. So let's add that one as well. So we added the backend, and next the configuration, which is the routing rule. Okay, so let's add the routing rule here. For the routing rule, we can call it rule 1, for example, and we can give a priority, let's say random priority, let's say 100 or 50 number as a priority. Then we can call it, it basically priority comes into the play when you have multiple rules, but right now we have 1 rule, so it's not actually important at this stage. We can call it the listener. We have to define a listener. We can call listener 1. Front end is public, HTTP traffic, and is basic type, and it's fine. Let's go to the backend target. In the backend target, you have to define the target type is backend pool. So we already have a backend pool, and we also have to define a backend setting. We have to create a backend setting. So let's call backend setting 1, and that's it. I'm not enabling any cookie based affinity here right now, and there is no path based rules required at this stage because we're not doing any content based routing using application gateway. So let's add that one. So we have front end IP, which we define a new IP, public IP, we have the rule 1, the routing rule, and we have backend pool. In the backend pool, we have 2 web servers. Now this application gateway is actually being deployed in VNet 01, so it should be able to resolve the fully qualified domain of our web servers, so it should work. So let's review and create, and let's pause my video. The deployment is started, and let's pause my video, and I'll come back once the application gateway is fully deployed. We have added the another application gateway in East US region. The configuration of the application gateway in East US region is exactly the same as that we have in India region. As you go back and check the backend pool configuration, it's same thing. We have the two targets, web01, web02.taslab.com. That's important part is that because the VNet, we have the VNet link from private DNS to VNet 02. So application gateway in East US region, which is sitting in the VNet 02, should be able to resolve the fully qualified domain name of the web servers. However, the most important part of our design is that VNet 02 has no VNet pairing with VNet 01. So it would not be able to reach our web servers which are sitting in VNet 01. So as a result of it, if I go back to my App India region application gateway, and if I go back to my backend and check the backend health of my pool in India region, it should be green because web servers are in VNet 01, and India application gateway is also in India region VNet 01. So as you can see, it's able to reach out to the web servers and everything looks green for the application gateway in India. However, if I have to wait for the deployment for the East US region to complete, and then once it is complete, we'll come back and check the configuration of the application gateway East US region. As per our design, it should not be able to reach our VNet's web servers, and the backend health on the backend for application gateway in East US at this moment should be red. So let's pause our video and wait for the deployment for application gateway in East US to complete. Our application gateway East US region is complete, deployment is complete. Let's go to the backend pool and check the backend health. We are expecting that it will give us red signal that is not able to reach the web server, so the health is not good, which is what we're expecting basically. So as you can see, both of the web servers are responding unhealthy because there is no VNet pairing exists between VNet 02 where this application gateway exists and the VNet 1 where the web servers exist. So at this stage, we have deployed the application gateway. Let's go and configure our traffic manager. When you configure the traffic manager, it's a global offering. So let's define our traffic manager. Traffic manager is a global offering from Azure, which will actually able to route the traffic to the endpoints. Those endpoints could be Azure services, like for example a public IP or any other services. There are different kind of algorithms or routing methods are available with Traffic Manager. As you can see here, you have performance, weighted, priority, geographic, multi-value, and subnet. For our DR region, DR design or disaster recovery design, we wanted to route the traffic to our application gateway in India region all the time, and we only want to send this traffic to application gateway in East US region, which is our DR region, only if the application gateway in India is down or the web servers in India are down. So basically let's go ahead and as per our design, I'll define traffic manager profile called KSORG, and we select the routing method. You can change the routing method at the later stage as well, but let's do priority based right now. And resource group is test RG, and we'll just create it. So this traffic manager, when you deploy it, you will get a fully qualified domain name, and that fully qualified domain name is very, very important because it will give you an opportunity that if you have, for example, if you own your own public domain, you can go to your public domain registrar and create a CDM entry pointing back to this fully qualified domain name, and that way you would be able to access your website which is running on your web servers behind the application gateways. So let's wait for the deployment to deployment is completed. Let's go quickly to the deployment is complete. So let's go to the application, let's go to the traffic manager, which is traffic manager. Let's go to traffic manager profile. We have KSORG is ready right now, And here, as you can see, there's an option called endpoint. So we have to configure the endpoint. Let's add the endpoints. We will add the endpoints to the public IP addresses of our application gateways. So we can call it app gateway endpoint India, and type the cloud resource type is public IP address, and we will give the India application gateway. Now here it actually complains that the DNS name is not configured, so we have to configure the DNS label. So let's configure the DNS label of these public IP addresses and then complete our DNS our configuration for the traffic manager. To add the DNS label or DNS information, let's go to the public IP. This is the public IP of our our application gateway in the India zone. Sorry. So let's go back to this is public IP and public IP which is associated to our application gateway in India region. So let's go and check the configuration. And here's the DNS name label, which is optional, but you can say public IP India app gateway. It complains about it, so let's call it public app gateway DNS. Okay, it's actually going into our subdomain, which was actually created from Azure. So just let's save it, and we will do the same thing for our public IP in East US region. So let's go back and do the same thing for our public IP in let's go to the public IP addresses. The second public IP address is the US region one. So let's go to the configuration, and we can call it so now we have defined the DNS labels to our public IP addresses of our application gateways. So let's go back to our traffic manager, which was already configured. Let's try to add the endpoints right now, and we can call it app gateway India region, and the public IP is this one, and then you have to put the public IP of India application gateway, put the priority high 1, and now as you can see, the error which we're getting earlier for the DNS label is gone now. Okay, so we added the first endpoint, which is our public IP of our application gateway in India. Let's add the second one as well. Okay, and then again public IP, and choose the second public IP, which is this one, and put the priority, the lower priority, let's say 100. So now we have added our 2 endpoints to our traffic manager profile. Now what we have to do is let's have a look on the configuration itself. So configuration looks okay. We have put the DNS routing method as priority based, so everything looks okay to us. Let's check the properties. Yeah, so this is the DNS name, ksorg.trafficmanager.net. So a quick way of testing is that we can just copy this one and try to open a new link. As you can see here, if I copy paste this one and let's put on the browser, as you can see, it is going to our application gateway in India region, and application gateway is sending it to web 01 or web 02. So everything looks fine at this stage. One thing which I really want to do in the case of the production environment is that if you own your own public domain, for example, I own, for example, a public domain DNS, which is id.ca. I have to go to my public registrar and create a CNAME entry, as you can see in my design document as well, that if I have a public domain, I can always create a CNAME entry in my public DNS registrar, which can redirect the traffic to ksorg.trafficmanager.net, which we already have here as our DNS name of our traffic manager. So hit id.ca right now, it is redirecting to my my traffic manager, and my traffic manager is redirecting it to web 01 or web 02. Traffic manager is redirecting to the application gateway in India, which is sending the traffic back to one of the web servers. So it is actually working. Our design is working right now, and so we will move to the next step, which is enabling the site recovery for our web servers and complete our DR configuration. So let's go to the next step, which is enabling the ASR for web servers. So enabling the ASR, as we have already seen in our earlier videos, is very straightforward. We go to the disaster recovery. I'm right now on web 01, and we don't require the disaster recovery between the availability zone, but we require the disaster recovery across our region. So our DR region is in ES-US, as you know. So we'll take ES-US region. Let's check a quick look on the advanced setting. So as you can see, it's creating a test arg-asr. It's creating a separate VNet in that region, VNet 01-asr, and I will put in the availability zone. As you can see that if I'm configuring for web 01, it will, and I'm saying the availability zone, it is going in the physical zone AZ2. You can always change it. Let's say if I do the ASR for my web 02, I will put in AZ1, for example. So let's say web 01, let's put in AZ1, for example. The second machine will put in AZ2. And review and install the application. Nothing else is required here. As you can see, we're enabling it. What it's going to do, as we have seen in the earlier video as well, it will create a vault, service recovery vault in East US region. So let's start the application. So we have to wait till a few minutes till the target resources are completed. In target resources, it will create the policy, their application policy. It will create the vault. It will take some time. And so I'll pause the video and come back and do the same step for my second web server as well. However, I have to make sure that I am selecting a different zone in ES-US region when I'm enabling the replication for my second web server. So let me pause the video and come back again. So if I go to the backup center, as you can see here, it is actually enabling the replication. It is creating a site. We have to wait at least 15 20 minutes or 30 minutes for our application to finish. Please note that I'm replicating both of my web servers, web 01 and web 02, from my India region to the East US region, which is my DR site. And I have made sure that both of the web servers are being replicated with separate zones in East US region. So let's wait for this replication to finish. Once the replication is finished, then we'll come back and we do the site failover, and we will see how the overall solution will behave at that point from the disaster recovery point of view. At this stage, while our ASR application is still going on, if I go to my application gateways in US region, let's say if I go to APUG region, and if you remember that we have not added any backend targets to our backend pool, but even if I add the targets to my backend pool, and if I say web01.testlab1.com, and if I add, let's say, web02.testlab1.com, it still we should be okay, because we don't have a VNet pairing between VNet 02 and VNet 01 at this stage, and we don't want to do a pairing between VNet 02 and VNet 01. Remember that VNet 02 is the one where the application gateway in US region exists, while VNet 1 is the where the VMs in our India region exist. So there are no links. So at this stage, I don't see any issue here. Let's go back to our backend pool health, and I'm sure that it's going to give us a red sign that these servers are not accessible, because we don't have a pairing between VNet 2 and VNet 1. So as you can see, it's unhealthy, which is perfectly fine. It's unhealthy, that's good, no issues at all. That's what we expected. We can always add a probe as well. Let's add a probe as well. You can call it dr probe. You can say web01.testlab1.com, and we can call it iis start.html file, and we can add the backend 02 setting, and we can test it. We know that the testing will not give us any good green status, but let's add this health probe as well, so that we are preparing it for them from the disaster recovery perspective. And remember that we don't have the VNet pairing, VNet 1 and VNet 2, so that's fine. We will have a red sign here in this configuration for now. So let's wait for probe to complete. Expected, it's saying that backend instances are unhealthy, which is perfectly fine, because this is our DR application gateway. Now, one thing which is very, very important is that if you look into the our private DNS zone, so this is the private DNS zone, and if we see the virtual network link, we have the link to VNet 01 and VNet 02. Let's add another link to VNet 01-ASR. Add link to VNet 01 ASR, and we also enable the auto registration. Take some time, it's coming. So let's go back to our VNet pairing. So let's search our VNet pairing. So let's go to VNet 01, VNet 02, and go to the pairing. We have to pair this one with our ASR VNet. So let's go to the pairing, add a pairing here. We can say VNet 02 to VNet 01 ASR, and we are allowing VNet 02 to talk to VNet 01-ASR. We can say VNet 01 ASR to VNet 02, and the remote side is VNet 01-ASR. So we're adding a pairing between VNet 02 and VNet 01-ASR. Remember that VNet 02 is the VNet which contains the application gateway in our India region, in our central, in our East US region, and VNet 01 ASR is the ASR VNet which was created by Azure Site Recovery. So let's add this one. As you can see, it's updating. and we have to wait till this pairing is complete. Okay, so our pairing is complete between VNet 02 and VNet 01-ASR. So at this stage, we're just waiting for ASR jobs to complete, and then we will start our site failover activities. So we checked our status right now. As you can see here, our Web 01 and Web 02 are actually being still protected, and the status is still 0% synchronized, so we have to wait. If you go into the more details, you will see there is no health. It's 6% synchronized basically, and it's doing its job as expected. And Web 02 is 32% synchronized, so it's progressing, and we have to wait till our ASR replication is finished completely successfully. So let me pause the video and I'll come back once this synchronization is 100% completed. Okay, so at this stage, our application, ASR application, is completed. As you can see, the RPO for Web 01 is 1 minute, and it's healthy. The replication health is healthy. And let's go and check Web 02. The RPO is 9 seconds. The achieved RPO is 9 seconds, and the replication status is also healthy. So at this stage, we are ready to do the failover. And just to let you know again, let's go back to our website and check how it's working. As you can see, it's working fine, no problems at all. So let's start our failover process and see how the failover works. So let's go back to our backup center, and let's do a failover. So let's go to our ASR replicated Web 01. There is a warning message says that you have not done the test of the failover, but that's fine. We have done the test failover process in our earlier video. So let's try to do the failover of Web 01. And when we do the failover, we're saying understand the risk of skipping the test failover, and we'll continue the failover, and we're also going to shut down this Web 01. So that's started again. Let's go back to our Web 02, and we again do the test failover here. We're doing the actual failover for Web 02 as well, and we understand the risk for skipping our test failover, and we shut down the VMs as well. So at this stage, if I go back to my website, and it's still working because the web servers are still up and running, but within minutes, the VMs, the virtual machines, will shut down, and the failover process will trigger the site failover process, and as a result of which, our web servers copy of the replicated VMs in East US region will be up and running. So as you can see, the as a part of the site failover process, the Web 01 is now shutting down. This is actually the simulation of the actual failover, because it's very important to note down that we cannot do the simulate the failure, the site failure of our application gateway, because we don't have the control of shutting it down or something like that. But what we could do is to just do the failover of our web servers. So it's still doing deallocating Web 01. If you go back to our website right now, still should be up and running. Yeah, it's still up and running. It will take some time to do the failover. Meanwhile, what we can do is wait for a few minutes and see what happened. As you can see, both of the web servers in Central India region has been stopped. You can go to the backup center and see the status, what's going on. Let's go to the backup center and let's check the ASR jobs. As you can see, that the failover process for both Web 01 and Web 02 is in progress. It has shut down the Web 01 and Web 02 in Central India region, and it will probably start the ASR replicated copy of these two web servers in East US region very soon. So let's wait for a few minutes and then we will come back again. So as you can see that the site failover process still going on. It has started the VM Web 01 in East US region, and now it's going to start Web 02 in East US region. So we'll wait for a few more minutes. Yeah, it's up and running. At this stage, if I go back to itdap.ca, we have to still wait because our application gateway will take some time to refresh. So let's go back to our application gateway first, and let's check the status in US region. So it's taking some time. Let's wait for a few more minutes. So at this stage, I think our process, the web servers are up and running right now. If you can go back to the web servers, as you can see, both of the web servers in test RG-ASR are up and running in Central and East US region. So let's go back to our application gateway and let's go over application gateway US region. And it says that the instances are unhealthy, but if I go to backend pool and let's check the status, let's go and check the backend health of the web servers. Remember that we are now in US region, and we are checking from the application gateway back to our ASR replicated VMs. As you can see, both of them are up and running, healthy. The status you are getting is because I think we didn't configure the probe on this US region, but essentially they're up and running. So if this is correct, so we should be able to see our website up and running in US region right now. As you can see, it's up and running. So this means that our design worked, and as you can see here, we were able to do the site failover using a traffic manager, priority based algorithm, two web application gateways on the back end with the two web servers, and the web servers were actually the Web 01, Web 02 in India region, and then we're replicating through the ASR to our East US region, and we are able to make the website up and running within a few minutes. Essentially, it's a very good design. It's a little bit costly as compared to our earlier design option, because we have two application gateways here. One is in Central India and one is in East US region, and we also have a traffic manager. But essentially, it gives you a very low RTO and RPO in case of a disaster or site disaster. Hopefully you like this video. If you like this video, please subscribe to my channel, and I will see you in the next video. Thanks a lot.